Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the third online lecture of power generation course, which is about important parts of boiler. The helping material are available in these resources. We have already discussed that in the last lecture that boiler is one of the very important part of coal thermal power plant, and today we will discuss the boiler in more detail. Actually, we will discuss the parts of the boiler in the detail. You can see in this schematic that different rows are mentioned here, which shows that some things going inside the boiler while something going outside of the boiler. So these all the arrows which shows different processes are mentioned here. I mean, these processing need some details, which is fuel treatment. So first of all, the fuel entering to the this combustion chamber will be discussed in detail. Then we will discuss the air preheater. The air is here and it goes inside, so it must be treated before entering to this chamber to increase the efficiency of this boiler. So this will be discussed in detail. Then the feed water, which are shown here, and when this water is going inside the boiler, so it will be discussed in detail. So to increase say that how we can increase the efficiency of this boiler and overall efficiency of the power plant. Similarly, an economizer is shown here, and when the feed water flows through it to the turbine to the boiler, so it will be discussed in detail. Furthermore, the flue gases which are going outside of this boiler when the combustion occur here, so the flue gases goes outside, and when it goes outside, so we need to treat this so to avoid pollution creation of pollution in the environment. Furthermore, we will discuss the feed water treatment. The water which is going inside this boiler must be treated to avoid the corrosion of tubes and the drum of the boiler. So we will discuss all these in the lecture, in this lecture in detail. So let's come to the first part, which is actually the fuel treatment. I mean, the fuel is here is coil, and when the coil is entering for the combustion, so we take coil from the coil from the mines, and it's just like rocks, so it's of irregular shape and irregular size. So first we have to render it to convert it to some specific size to make the regularity and make the combustion easy. So you can see in detail the lecture 1, we have already discussed it, but to further discuss it, we have to the process in which we treat this fuel is actually we are converting the rocks of the coil to some powder like material, which is, and this process is actually called pulverization. So this pulverization has many advantages, but definitely there are some disadvantages too. So the advantages are mentioned here. It increases the efficiency of the boiler. Further, it makes possible the use of wide variety of the coil. It reduces the time of raising temperature of steam. For example, when there is variation in the load or a plant is going to start, so it takes time. So this is actually this reduction of raising temperature, time of raising temperature is helping in that sense. So by using pulverized coal, the process actually decreasing the time of rising temperature. Further, you can see that combustion of pulverized coal is readily to be adopted like automatic control. Because due to the powder form of the coil, it is easy to use some built like a carrier for the coil, and it's easy to make it automatic, and the burning of this is has some regularities. So it is very important advantage of the pulverized coal. This system can also work in combination with the other fuel like gases, because the pulverized coal also burn like gases. Large amount of heat releases is possible in this system compared to the stroke firing system. So similarly, when there are some advantages, so definitely there are some disadvantages of this system. The additional cost of the and complication of the equipment. I will show it with some clip in this lecture, so that you can imagine the cost of the cost and complexity of the system. 40% of the ash passes up through the chimney and spread itself upon the surrounding, which is too much dangerous for the environment. So the air before going outside must be treated, and that is actually increasing the cost of the system also. So although it increases the efficiency, but it increases the cost and increases the processing, and it will also and the processes also take time. So that is also the disadvantage of this system. Specific efforts are required to made to precipitate most of the ash. As in this section we have discussed that the ash goes outside with the flue gases. So to precipitate it from the flue gases, it is quite difficult process. Some electrical and mechanical processing is need for that. So that increases the cost and the complexity of the system. The possibility of the explosion is more as coal burn like gases. So as we have discussed it here, that it is work with other fuels. So why it's work with the gases and oils? Because it's also burn like gases. So it is also dangerous, and that is why the storage of the powder coal requires special attention and high protection from the fire hazards. Let us see the whole process in a small clip of video.
In recent times, pulverized coal has emerged as the most widely used fuel in the steel re-rolling mill sector. However, in order to get the optimum output, it is important that the supply chain of coal is properly maintained. The coal typically used in the SRRM sector is characterized by high ash and low calorific content. This leads to premature cracks and failure of the refractory lining. Ash deposits require more heat to be added to the charge for attaining the desired temperature, thus increasing burning losses. Also, high ash content leads to choking of the recuperator tubes. This necessitates frequent cleaning, thus high maintenance cost and reduced performance of heat exchangers. The ideal size of pulverized coal should be at least 75 to 80% of 75 microns. In the conventional systems, fine coal ranges from only 10 to 30% of 75 microns. Non-uniform coal particles undergo partial combustion and result in deposition on the furnace walls. These coarse particles escape from the furnace with flue gas in the form of unburnt carbon or ash. The energy-efficient alternative to using pulverized coal as fuel starts with the procurement of good quality coal. Coal with high calorific value and low ash content, for example, Assam coal is the most ideally suited for use as pulverized coal. The next step is to process or pulverize the coal into the desired fineness consistently. To do so, certain modifications in the pulverizer are required. The critical components of a pulverizer are a hammer, a mild steel liner, a classifier, and an inbuilt blower. For better and long-lasting quality of pulverizer, the metallurgy of the hammer should be improved to increase its resistance to wear and tear. The suggested additions to be made while casting of the hammer consists of manganese 13%, carbon 1.13%, silicon 0.4%, sulfur 0.003%, and phosphorus less than 0.2%. Proper dimensions and thickness are to be ensured in the classifier. Grooved EN31 hardened steel plates or casted high manganese should be used in the liners. This will help achieve 65 to 80% of the desired 75 microns. The performance of a coal pulverizer can be gauged from the size and uniformity of the coal output. Let's take an example of a 10 TPH rolling mill to understand the economics. Typically, a furnace will have an annual fuel consumption of 3 crores 24 lakh rupees. With the use of energy-efficient system, the savings in specific fuel consumption shall be about 15%, which implies savings of rupees 16.2 lakhs annually. The modified pulverizer will entail an investment of 7 lakh rupees. Thus, the investment can be recovered in less than 5 months. For ensuring optimum performance, a pulverizer should be regularly maintained. The pulverizer components should be replaced periodically. It is proposed that a bomb calorimeter be used for in-house quality checks of coal. A metal sieve of -200 mesh size or 75 microns can be used for measuring the coal output.
Now, as you have seen that how the fuel, the coal is treated before entering to the combustion chamber. Similarly, the air which is going inside for the which is required for the combustion is also need to treat, to improve its quality for burning. So for burning, the hot air is actually more efficient as compared to the cool or the low temperature air. So you can see there that air coming inside from here to go inside this chamber, and with the burning of the coal occur here, so ash goes outside from here, but the flue gases goes outside from here to here. So you can see that these flue gases are going outside, and that is actually the byproduct of this system. So we need to convert this flue gases to take some important work from it and utilize it. So we can use an air preheater. Preheater mean that air going before the chamber should be heated here. So the air preheater is used here, which uses the flue gases going outside for heating the air which is going inside for combustion. So let us discuss this in detail. An air preheater is any device designed to heat air before another process. For example, combustion in a boiler, with the primary objective of increasing the thermal efficiency of the process. There are two types of air preheater: recuperative preheater and regenerative preheater. In recuperative type heaters, the two fluids are separated by heat transfer surfaces. One fluid flowing constantly on one side and the other fluid on the other side of the surface. You can see it here with uh, the help of this figure. You can see it here. So air goes on one side, gases goes on one side, and the air goes on other side. So the gases come from here and goes outside from here, and air in from here and goes outside from here. So from here the air at outlet is heated off with the help of these flue gases, and this type of preheater is called plate air preheater. From the figure you can see here, this is in a tabular form. Therefore, this type of preheater is called tabular air preheater. Similarly to that, there is another type of preheater which is called regenerative preheater. It consists of a rotor, you can see from here, this one, made of corrugative elements. The rotor is placed in a drum, you can see it here, which has been divided into two compartments, one and the other. Air and gas in one compartment there is air, and in the another compartment there is a gas. To avoid leakage from this one compartment to the another compartment, the seals are provided so that it may not mix with each other. And thus when with this rotor, the air is heated off because these are the metals, and get heated by these gases, and when it's come to this side it give the heat to the air, and then air is going outside from here, and then that is used for combustion. There are the regenerative air preheater is has some advantages over the recuperative air preheater. The most important was is the compact size and easy to clean, and due to the compact size suitable for large scale power plant. So in the large scale power plant, mostly the regenerative air preheaters are used. The other advantages of regenerative over the recuperative air preheater are here. You can see it here. We are going to discuss now the another part, which is also very important part of the boiler, that is a feed water heater. The feed water heater make a very important role in increasing the efficiency of the thermal power plants. We are going to discuss it slightly here, and the more detail will be discussed, the will be provided in the lecture when we will discuss the heat cycles, because it plays a very important role there. So we will discuss in more detail there, but as it is the part of the boiler, so we are going to discuss it here also. So before going to discuss the feed water heater, we should know the bleeding process a steam of a steam turbine. So the bleeding of steam is actually when we take steam from the steam turbine, just like as shown in this figure. We are taking steam from here, and when we enter this steam to the feed water heater, it is called bleeding of steam. So this is the very important phenomena which you should know before going to discuss the feed water heater. So now the feed water heaters are of two types. The one is open feed water heater. The open feed water heater mean that the water comes from this side and goes from this side, and this steams is extracted from the turbine. So this steam mix up with this water in this chamber, and therefore it is called open feed water heater. You can see in this diagram that at point 6 we bleed the turbine here and take the steam from here, which enter in this free feed water heater, and the in similar and at the meantime you can see that water enter from point 2, and this steam and the water mix up, and the resultant one is the heated water. And when heated water enter in the boiler, it increases the efficiency of the power plant tremendously. Similarly, you can see here, this is another type of feed water heater, which is called closed feed water heater. The closed, from this name you can see that you can easily recognize why this type of feed water heater is called closed, because the steam which is bleeded and enter to this chamber. So you can see that the water goes in this tube, enter in this tube and goes out in this tube, and does not mix up with the water which is heated off, and the heat is transferred to the water through this tube, which is definitely metallic and good conductor of heat, and the heat is entered to the water, and the steam is converted to liquid form or to water, and this is sent for further processing. It may be sent to the condenser or may be mixed off with at some other places with the water. So therefore this type of feed water heater is called closed, and you can see it in this diagram. At point 5 the turbine is bleeded and the steam is entered here in this chamber. At point 2 closed, in the closed pipe or tube water is entered and it is extracted at point 3, and the steam and the water are not mixed off. Therefore, it is called the closed feed water here. I hope you have understand it. Now we are going to discuss the another very important part of the boiler, which is economizer. This is also shown with this arrow here. Economizer and preheater has same working uh, because it is also used to heat up the feed water, but it is not the name as the heater, it is named as the economizer. The main difference in feed water heater and economizer is that it use flue gases for heating the feed water, but in the feed water heater we uses the steam which is bleeded from the turbine. So as I have told you that in the economizer we uses the flue gases which goes to the chimney and we pass it through the heater, which is just like in the shape like this. So we can use these heaters to extract heat from the flue gases which are already going to outside to expel it to the environment. So we are using that heat which is just like a byproduct, and we use that to heat off the flue gases, heat of the feed water, so it increases the efficiency of the power plant, and cost is nothing. The only cost is the capital cost. I mean, to make it to construct it. The main cost is to construct it on the in with the boiler, and it also produces some friction because we need to expel the flue gases easily, so it will provide some friction to that in the way, because that will not go steadily outside, so it will, otherwise it has no effect and cost other than that. Economizer is actually heater, so in water come inside from this side, come in from this side and goes out from here, and these you can see the pins here. It is actually to increase the surface of the pipe or the tubes to take more heat from the flue gases. So these pins are constructed here. Economizer, just like other parts, economizer are also has many types like steaming, non-steaming, straight tube or bent tube, independent or integral, which can be studied in the textbook which is provided. The main advantage of the economizer is fuel economy from 5 to 15%. Similarly, increase in the boiler efficiency by 10 to 12%. So the two advantages. One is the economy, I mean decreasing of the fuel, and increasing the efficiency of the boiler. Reduces the temperature stress in the boiler joints because of less range of temperature. Because the as the we enter the heated water or the hot water to the boiler, so it will increase the temperature from that range to the saturation range of the steam. That is actually, so as the range decreases, so the stress on the boiler joints also decreases. So the disadvantages, the main disadvantage is the cost of the installation, maintenance, and extra floor. Otherwise, no running cost is required other than these. As we have discussed in the previous slides, that feed water preheater and economizer are working just like same, but both uses different mechanism to heat of the feed water. One uses the steam which is bleeded from the turbine, and another one uses the flue gases. Therefore, it is not necessary that if one, for example, if one part is available or one mechanism is available, like economizer is available, so it is not needed that the feed water preheater, which is using the blade steam, cannot be used. So both can be used, or any one of the two can be used. Or maybe if the small scale boiler is used, so it is not necessary at all to use any one of it, but it definitely increases the efficiency. So if it is available, it will be quite better. And if both of them are available, so it will be far better. Now let's come to the another part of the boiler, which is the treatment of the flue gases. When the flue gases goes outside, it takes some ashes, which we have already discussed in the this part, that when we are actually using the pulverized coal, and that burn like gases, and the flue gases take some ash with itself with it, and that when the ash goes outside, it make the environment polluted. So to decrease that pollution, we must have to treat the flue gases before going outside. So you can see from this figure that before, so you can see from here that the flue gases enter here, and it goes outside from this chimney, and before going to the chimney, it is passes to multicyclone, where we separate ash, and in the dry cyclone, a dry reactor where we extract sodium bicarbonate and activated carbon, and then we pass it through the bags filter, which you can see here, and residue cellulose can be extracted from here, and then we pass this flue gases to this chimney, and it goes outside at some height. And when it expel to the environment, it create less pollution as compared to the flue gases if the flue gases are not passed through these filters. Now let us going to let's to discuss now let us to discuss the feed water treatment. Although we know that the water should be heated off before entering to the boiler to increase the efficiency of the power plant, but it is also very important to treat that water before entering to the boiler. Otherwise, it will damage the boiler because the water may contain some oxides and other impurities which, if enter to the boiler, it will precipitate on the surface, or it may make the corrosion of the surface of the tubes, of the heaters, or of the surface of the boiler. So to avoid the damaging of these the material of these boiler and tubes, we have to treat this water before entering to the boiler process for the boiler to enter to the boiler and its parts. So you can see here that actually we have two categories of impurities in the water. The first group is including mud, slate, clay, and silica, etc., either in suspension or in colloidal form. And the second group is actually consist of calcium carbonate, calcium bicarbonates, calcium sulfates, magnesium bicarbonates, magnesium carbonates, sodium bicarbonates, sodium sulfates, magnesium sulfate, nitrate, etc. These impurity deposit on the heat transfer surfaces in a farm in a power plant. These material like dirt and scale have low conductivity and therefore impede heat transfer from severely. When these when these impurities enter to the boiler, for example clay or silica, etc., mud, so it adds off on the surface of the boiler or in the tubes, and as these are bad conductor of heat, so it decreases the deficiency, it decreases the efficiency of the power plant or of the boiler, and also it make the surface through which the water flows narrow, and later if it increases and it is quite difficult to maintain the or to remove it from the surfaces from the inside of the tubes. So therefore it is most important to not make enter or make not make entry of these impurities to the boiler. So impacts of these impurities is are actually scaling, corrosion, embrittlement, carryover, and gases. Water hardness is the scale forming property of water and destroying the power of standard soap test solution. There are waters having carbonates or non-carbonates hardness depending upon the nature of the impurities present. There are some methods which are explicitly discussed in the textbook. I have just mentioned its name here. So the methods to treat these water is some are mechanical, thermal, and chemical. For example, the filtration like things coming lies in mechanical. Distillation or diureting is the processing of heating, and lime treatment, soda treatment, etc. like processes are lies in the chemical. And these are discussed in the textbook. You have to read it from there. It is also important to note that cooled it can the cooled water can be treated, but for the best result we have to treat hot water. Cool water can also be treated, but for the best result we has we have to add of some heat to the cool water, and then we have to treat it. And this is all about important components of boiler or parts of the boiler. And in next lecture we will meet again, inshallah. And we will meet again in the next lecture, inshallah. Allah Hafiz.